The drill stopped at 43 centimeters below the Martian surface, not because of a mechanical failure and not because of a command from Earth, but because what the sensors returned made the scientists on the other side of a 300 million kilometer signal go quiet. The sample was ancient, roughly 3 billion years old. From a geological formation, planetary scientists call Cumberland a name that may soon mean far more to humanity than it does today. The rock had been sitting there undisturbed, compressed under Martian time, through an era when Earth itself was still cooling from its own formation, and inside that rock, in concentrations no instrument had ever measured before on another world, there were molecules, long-chain organic molecules, ordered, complex, present, at levels that exceeded every known non-biological Martian process by a factor that refused to cooperate with any natural explanation. The team ran the numbers once, then again, then a third time using a completely different methodology, and the answer did not change. Every non-biological explanation they tested, and they tested, every single one failed. Not partially and not with minor discrepancies, but completely. One hypothesis survived. To understand why this discovery matters, you need to understand what alkanes are and why their presence in a Martian rock sample is extraordinary. Alkanes are a class of organic molecules found everywhere on Earth, in crude oil, in biological membranes, in the fatty tissues of living organisms, and at their most fundamental level, they are the chemical fingerprint of biological activity. When living cells process energy, when membranes protect genetic material, when microbial life breaks down and fossilizes over millions of years, alkanes remain. The molecules found inside the Cumberland sample were long-chain alkanes ranging from C15 to C35, a range significant because short-chain carbon compounds can be produced abiotically through processes like Fischer-Tropsch synthesis near hydrothermal vents, but long-chain alkanes in this concentration range and molecular distribution pattern are associated almost exclusively with the biological processing of fatty acids. On Earth, this molecular signature has one primary source, life. The concentration recorded were not trace and not marginal. They measure between 40 and 310 parts per billion across multiple drill sites within the same formation, roughly 10 times higher than trace organics detected by previous Mars missions, forming a structured, repeatable, high-concentration molecular profile aligned with the biological production curve derived from Earth's geological record. In science, the first instinct is doubt, not excitement. So the team set out to destroy the biological hypothesis by testing every alternative explanation. Meteorites were examined first. Carbonaceous chondrites carry organics, but isotopic analysis showed the carbon 1:3 ratios in the sample were consistent with low-temperature aqueous processing on Mars, not deep space chemistry, eliminating a space delivery. Interplanetary dust accumulation was calculated and found to be 2 orders of magnitude too low to account for the measured concentrations, requiring an unrealistic 100-fold increase in dust flux, so that hypothesis was eliminated. Atmospheric photochemistry was tested against molecular complexity and depth distribution, but UV-driven reactions produce short-chain molecules and surface gradients, while the sample showed long-chain complexity and increasing concentration with depth, so atmospheric chemistry was eliminated. Hydrothermal synthesis through Fischer-Tropsch processes was the most serious contender, yet its predictable Anderson-Schulz Flory distribution curve did not match the data. Instead, the sample showed elevated C17 and C19 odd carbon alkanes, producing a carbon preference index of 2.8, whereas abiotic synthesis approaches 1, a pattern on Earth recognized as a biomarker of biological fatty acid degradation. Hydrothermal chemistry was eliminated. Contamination was rigorously tested against known spacecraft organic signatures like polysiloxanes, phthalates, and solvents, but no contamination profile matched, and isotopic signatures aligned with Martian geochemistry, eliminating terrestrial interference. 5 suspects, 5 eliminations, 1 remaining explanation. The long-chain alkanes are most parsimoniously explained as fossilized remnants of biological activity. The researchers did not claim they found life. They stated the molecular evidence is consistent with a biological origin and no non-biological explanation fits the data, a conclusion published in peer-reviewed Science in February 2026. The finding remains incomplete because chirality analysis and full carbon isotope fractionation tests requiring a Mars sample return mission have not yet been performed, and that mission currently faces funding uncertainty despite sealed samples already cached in Jezero crater. If confirmed, the discovery would suggest life arose independently on Mars during the same epoch as early Earth life, reshaping our understanding of life's prevalence and reframing the Fermi paradox. If disproven, it would represent one of the most profound negative results in science, redefining the rarity of life. Either outcome changes us. The drill stopped at 43 centimeters. The sample was sealed in a titanium tube and left in a Martian cache. And somewhere in Jezero crater, those tubes sit holding either the most important material humanity has ever collected or a chemical mystery awaiting explanation. The rock does not care, but we do. The question is not whether Mars holds the answer. The question is whether we will go and get it. The team ran the math, tested every alternative, and published what the evidence said after eliminating each possibility one by one until one remained. Now the funding, the politics, the engineering, and the decision belong to policymakers, engineers, the public, and to you sitting here. Having just walked through the molecules and the math and the elimination of every alternative, the debate shifted in February 2026. The rock is patient. The question is not